Welcome to Ask and Learn.
So for this problem, here we have an object, sphere, which is attached to the horizontal string of length L. Other end is fixed, and the ball is released, and when the ball is released, it will take this path and finally come to this location here. What is the speed at the lowest point? Which means we need to calculate the speed at this point of this ball. So in this case, only gravity is doing the work on the ball. So gravity does work on the ball. If the gravity is doing work on the ball, so mechanical energy is conserved since there are no non-conservative forces. So we'll have V1 at this location is 0, and the height Y1 is equals to L, because this whole distance is actually equals to L. And at this location, we'll have Y2 is equals to 0, and we need to find out the value of V2 at this location by the conservation of energy. So we have 1, and we have the location 2. So by the conservation of energy, we have E1 equals E2. So total energy at the top is just gravitational potential energy, which is mgl, and at the bottom is only kinetic energy, which is half mv2 squared. So therefore, the velocity v2 is, in terms of L, is 2gl. So that is the expression for A part. Now for the B part, in this scenario, we have a peg at this location. So a peg is there at that location. So what happens that this string, there is an obstacle at this point. So at this point, when it comes, then there is a circular motion which starts, and there is a peg which is at height h. So circular motion starts around this peg with radius equals to h minus L. So using conservation of energy for the points 2 and for the point, this is the point 2 now, and the points 3. So circular motion starts at this location here, and this is the center of that circular motion. And when the ball faces this obstruction, the string faces this obstruction, then the circular motion will be in this direction here with the radius of h minus L. So this is the location 3 here, and this is the location 2. So we can see here now, this location here, this location, this is not h minus L. This is actually L minus h, because L is greater than h. So this is L minus h, because this whole distance was L and this was h. So therefore the circular motion is with radius of L minus h. So when the object reaches this location from this location, the total height gained from this location to this location is 2 times L minus h. So therefore y3 with respect to the ground is 2 times L minus h, which is equals to 2 times L minus 0.8 L, because they're saying that the ratio is given as h to L as 0.8. So if you solve that, you will get 2L minus 1.6 L, which should give you 0.4 L. So that is the Y3 location. Now we set energy is equals E2 equals to E3 by the law of conservation of energy. And then we'll have the equation for the law of conservation of energy. I'll write here half m v2 squared plus mg y2 should be equals to half m v3 squared plus mg y3. So what we're doing is we're equating energies at 2 and 3. So now we'll just plug in the equation. So we'll get half m v2 squared was already proved 2gl, and y2 is 0 because this is the lowest ground level here. That should be equals to half m v3 squared plus mg times height, which is 0.4L. So if you solve that, you will get v3 as square root of 1.2 GL. So that is the answer to the